For the next presentation, we have terrain analysis for optimal pad site placement by Kris Berglund. Kris Berglund has been involved with digital mapping software for over 20 years. Kris offers a diverse level of experience in the fundamentals of cartography, geomatics, technical sales, and business development. Kris has a BFA from the University of Massachusetts and started his career in GIS with DeLorme Mapping in Yarmouth, Maine. Joining Blue Marble in 1999, Kris helped develop a winning strategy that has transformed Blue Marble Geographics from a niche software shop to a diverse geospatial systems organization, focused on the provision of highly accurate data translation services and easy-to-use GIS software solutions. So, Kris, thanks.
Good morning, everybody. Can you hear me all right? Yeah. You gotta love those marketing folks that write those bios. Here we go. So good morning. I'm as Harold had mentioned, my name's Kris. I'm with Blue Marble Geographics, and technically I'm the sales guy at Blue Marble, but initially I was going to present with another end user, but unfortunately after our talk got accepted, that didn't materialize, so I was sent down to make this presentation. And I've been briefed, I'm not going to do a salesy, demo-y type presentation, but I would like to walk you through a workflow that we were tasked to implement a few years ago with regards to optimal site pad placement and subsequent terrain analysis. Now, just to show of hands, how many of you have heard of Blue Marble Geographics before? Awesome, great, okay. So you probably think of Blue Marble and you think of, oh, those are the coordinate transformation guys. Those are the guys that take my data and reproject it from one coordinate system to another. And that's what we built the company on. About 5 years ago, that changed when we acquired Global Mapper. And Global Mapper isn't really something that's as well known in the oil and gas industry as it is in other markets like government, municipalities, and things of that nature. So this project that I'm going to talk to you about was brought to us by our good friends at Spatial Energy, and they have been working with Chesapeake Energy to work with our developers to create this site pad analysis tool. So as Miles had mentioned, you can see the limit of disturbance is one of the core focal points of this workflow. So what we were tasked to do was to give oil and gas companies the ability to find the optimum location of a pad site placement, thus calculating limit of disturbance and being able to flatten the pad site to a specific elevation. So limit of disturbance, folks probably know what that means. It's really just the boundary where you break earth, and that could be timber harvesting, excavation, road creation, grading of those roads, embankments, and it's also really going to give you the ability to set the proper permit approval levels that you need and to avoid trespassing on your neighbors, which is not a good thing. So, why did they want to use Global Mapper to do this? Initially, out of the box, it supports over 300 unique file formats. Now, that's it. I'm not going to get any more salesy than that, but it's a simple fact. So, some of the requirements you need to be able to do this workflow is the ability to load up a digital elevation model. Now, that could be something that's derived from a LiDAR point cloud or gridded off into a surface, and the ability to render polygons and join attributes and things of that nature. What we devised out of this workflow is the ability to use some of the pre-existing well pad templates that we and Chesapeake and Spatial Energy helped create. You can also import your own templates if you use those. I'm going to go through flattening the pad site polygon to a variety of elevation options. One of the main goals of this workflow was the ability to actually be able to, when you're flattening it to a specific elevation, you can also calculate the displaced volume that you're going to move out of that site and reincorporate it into the site, which is known as basically a break-even height. In that process, I'm going to also talk about being able to render a slope, either an angled slope or a bench and terrace around your flattened pad site. So Here's another view of this project here. You can see the limit of disturbance lines in the yellow poles. Where does this thing work? There we go. Limit of disturbance here, and you can see utility connections. You can actually see the drilling rig placement, the road access points. Again, the goal is to really reinforce that limit of disturbance, creating that boundary that's going to dictate where you're going to be able to create this site. So here's another view of the same area. This is more of a cross section or an elevation, and you can see the green line here in the diagram, which essentially is what we're looking at in terms of terrain before we started doing these calculations. And that brown line is what we were able to come up with in terms of being able to, again, flatten that pad site to a certain elevation and calculate the material that's being calculated from the underlying digital elevation model. So the tie-in points here, basically here and here, also help define that limit of disturbance. And yeah, so there's just that's really what we were tasked to come up with. So let me show you how we did that. Basically, the first thing you want to be able to do is to orient your pad site. Now, there's two ways that we've given the user to be able to do that. You can just manually orient the pad site based on where you need it to be and where you think it should go. A lot of times users will use an elevation model, and they'll generate a contour layer from that to determine that. But we've also implemented the ability to automatically determine the best placement of that pad site based on the loaded digital elevation model. It's not a quick process. The software will actually go through in different directions and angles and try and optimize the placement of that pad site, but it's there as an option, and it's available to our users. We've also implemented these pre-existing well exhibit templates, and you can see here, well, that's how you would insert it in the software, and that's the template that we worked with Chesapeake to come up with, and you can see the little well pads in the center there, your road access points, your elevation points, things of that nature. So a word about pad site rotation. So the way the software will do the automatic pad site calculation is it tries to orient the pad site, and as you can see the lower right, so that it's parallel with the existing contours. The way it was explained to us is if you don't do it and you go perpendicular to contours, you're just going to create more displaced volume. So I don't know if this is visible here, but this is the option that you would actually, under the rotation scaling setup dialog, you'd be able to find that angle with the minimized cut and fill. And then you can also apply a scale factor, select a point to rotate that scale around. So this is really the meat and potatoes of what we determined. Now, these three graphics, I have a couple examples. The one on the far left, that's just basically your pad site polygon with the yellow boundary lines that you need to stay within. In the middle graphic here, that's the actual flattened site plan that we were able to generate using some algorithms that we incorporated into the software. That's a raster layer that can be then exported out to a 3D PDF or to one of these open data formats that was mentioned earlier, that is not really proprietary to any software format. It's just basically a raster layer. And then on the far right, the flattened site plan graphic is just, they've generated a contour layer to pinpoint the elevations of the areas of that area. So, other content that you can use that might be vital to this would be tax parcel data. So if you had a vector layer that you wanted to overlay to give some more context, you could do that. Different elevation models you could load up. So if you had different raster layers and you wanted to maybe even calculate the difference between the layers, you could go ahead and initialize that. You could load up any type of hydrographic features, wetlands, or anything that would allow you, when calculating this limit of disturbance, to avoid, ecological features. So This is the dialogue that we created to be able, that gives the user the ability to set this up. You can see there are 3 simple variables. The first variable is more than likely the most important. That's the one that focuses on the elevation of your flattened site. The second variable gives you the ability in decimal form to enter in your slope ratio. That third variable isn't used all the time, but it is an option if you're working in very mountainous terrain, like maybe the Marcellus region, where an angled slope isn't going to be stable enough. You have the ability to render a bench terrace setup. So I'll go and talk about those a little bit. So the first option of the first variable is the fixed height option. So if you know what height you want to flatten your pad site to, you can simply indicate it here. And we just went ahead and put in 900 feet as a test value to demonstrate that all of the flattening occurs from making a cut slope above the flattened site. And that will give you your 900-foot elevation. However, you can see here, you cross the property line, and that's not going to work. So we have other options that might work for you in this case. And this is really what the customer had come to us for and communicated to us. It was basically the ability to come up with a break-even elevation. Or anything you cut, you'll be able to reincorporate as a fill. So you can see that we have the cut slope here, and then your flattened pad site, and then the fill volume gets reincorporated there. That ended up coming in at close to 948 feet, about 50 feet higher than the original example, but you're within your own property line, so that's good. The third option under the first variable here is the ability to, well, it's very similar to the break-even height calculation, except in certain cases, for drainage or whatever reason, you're going to have 2 different elevations on each end of your pad site. So you would be able to flatten to area heights, giving you an elevation of 960 on one end and 948 on the other end. And you can see here, they've actually generated contours to further detail the elevation differences on that non-level pad site. Let's talk a little bit about slope. So slope essentially is that product of rise over run. So what we've done here is we've given you some examples on how we illustrate the different slope ratios and what that means to the slope rendering. So essentially, 1 foot rise over a 2 foot run will generate a 0.5 slope ratio, and that's going to give you a more steeper slope rendering here. Whereas in the bottom graphic, you can see we went with a 1 foot rise over a 3 foot run. Obviously, that's a smaller ratio number, and that's going to give you the ability to spread out your slope a little bit more. Terrace slope options, so you can see here, there's your limit of disturbance boundary. But for whatever reason, in this situation, it was thought better to come up with a 10-foot bench width and then a 25-foot rise. And that essentially gives you that 0.5 ratio there. But that allows you to essentially render that stepped option for more stability, the way it was explained to us. Now, once you have everything in place and you've done your pad site elevation calculation, your slope rendering, and well, obviously your orientation and your placement, you can do a 3D visualization and subsequently a fly-through with Global Mapper. So on the top graphic, you see we have essentially that cut and fill slope graphic as a raster layer, and that's draped over a digital elevation model that has an orthophoto draped over that. So that really gives you a good look and feel for the 3D aspect of the terrain here. You have your property lines up there just for integrity, and then your site grading layer, of course, and then the contours from that. And then in the bottom graphic, pretty much the same display, except to accentuate the 3D aspect, they went ahead and loaded up a 3D point cloud or a LAS file, And what they did is they colorized that last file based on the RGB values of your base layer to give you a more realistic 3D interpretation. Pretty impressive. So with this workflow too, you have the ability to do a fly-through, and you can essentially create an animation, save that off and share it with your client, with your colleagues or whatnot, and that'll give you a good sort of 3D scope. The three options that I think we put in there are you can just generate a vector and fly through along that vector path. You can plop a point anywhere on the middle of the pad site or nearby and then do a 3D fly through around that point, or what they call a fixed direction, which is basically a vector and you're keeping the camera or your head the same direction as you're flying through that vector. So that's the workflow I wanted to talk about. What do we do here? We determine the best pad site location, the elevation, and the limit of disturbance. We were able to calculate that optimum positioning of that pad site. We were able to flatten it to a specific elevation and calculate the break-even height of the material that you moved out and reincorporated into the site, and slope calculation and rendering, two different options, angled slope and bench and terrace slope. Of course, anything that you do in this workflow, you can export. Every layer is maintained separately, and you can either export everything together as a workspace or any of these layers separately and use them in other platforms like Esri or whatever you're really more comfortable using. That's really the nuts and bolts of this. I think I had way too much coffee here because I flew through my presentation, so there must be questions. Any questions? Yes, sir.
Can we take into account depth of topsoil?
Not yet. There are a couple things three things that we're talking about for future versions. The depth of the topsoil, soil compaction rates, that's been something that's been brought up to us, and reclamation, or the ability to determine the mass of certain displaced volume and being able to reclaim that well, I'm not exactly sure about that, but we are constantly working on this workflow to add new enhancements. Seth?
When we were talking with PASDA earlier, some folks were mentioning the age of the LiDAR data set that's available here. Don't you have the ability to actually go in and update your elevation model based on like pads that you placed and things like that?
Yeah, absolutely. The USGS, and I don't know how aware you folks are of this, but they're taking a pretty strong initiative to have a national LiDAR data set completed very quickly. I think they're well past the midway point of the country. And they do have the LiDAR data set, excuse me, posted on, I forget what the name of the USGS service is, but if you Google USGS LiDAR data, it'll take you right to the service. And it's absolutely free. And you can actually use Global Mapper to go right in and visualize and connect to any of these online data sources. PASDA would probably be one that you could do, no doubt. Other questions? Way in the back, sir.
Thanks. Couple things. One is, obviously, it's highways, railway construction, found some cuts and fills. We assume there's already applications out there for them. Was there any kind of looking around to see what's been done already for that type of application? This was very similar type of objective, balance cuts and fills. And secondly, what about sometimes export or a surveyor would have to go and stake that out in terms of giving grade stake that they can work with?
Okay, so the first question you asked is, have we identified further uses for this workflow that I've just demonstrated? Did I get that question right?
Well, the other way around. Were there other components already out there for the highways and railway?
Geez, you know, I don't know off the top of my head. I know in addition to the oil and gas industry, the Federal Highway Administration has taken a really good look at this workflow because of, you know, the ability to calculate volume when they're putting in, you know, miles and miles of roadbed, you know, what type of mass they're looking at. But no, I don't know the other options that are out there. Sorry about that. Second part of your question, I've forgotten. Sorry.
Okay. Just wondering, in terms of your outputs, we're assuming we're kind of the standard GIS outputs.
Yeah, absolutely.
For, you know, some sort of specific output for surveyors, for, you know, setting grade stakes so that they can then go out and actually build that.
Right. Well, I'm not going to get into all the formats that we handle, but for import and visualization and display, We support over 300. That's raster, that's vector, that's digital elevation model, that's seismic, that's LiDAR, compressed LiDAR. From that list of import formats, we can export about 120, I think. So you'll probably find what you're looking for. If not, give us a call, and our development team is pretty good at that hot fix mentality where they can write a quick dynamic import library and an export library and get you going with whatever file format you're looking for. Maybe we can talk offline and you can give me some more details on what you're looking at. Question, yes?
How quick can you turn something around using this?
How quick does the actual workflow take? Minutes? I mean, if you have all the pieces together and you're familiar with the workflow, you know, it's one of the things that we like to make people aware of when we visit them on site. We can do this workflow in literally 5 minutes or less, and it saves a lot of time and money. You know, you're with a few clicks of the mouse, you're pretty close to determining some of the information that it would take a survey team, you know, a week out in the field with all of their equipment. So it's a pretty economical way forward too.
Is it beneficial to your final design as well?
I would say so. You know, with a lot of the 3D presentation capabilities, I mean, you can really take this right to a client directly and say, look, this is what we did, preliminary studies. This is what we were able to do. What do you think? Other questions? Oh, yes.
I have a question. So this is like a preliminary, because I'm just wondering what happens when you put boots on the ground and you go out in a truck and the access to this pad location that looks good as far as like the elevation and things like that, but then the access is you have to go through a tunnel that a big rig can't go through, or I mean,
That's a great question. That's going to hinge largely on the quality of the data that you're using as part of the study, and what a lot of people, and Seth touched on this a little bit, what a lot of people are doing is they're generating their digital elevation models from some of these newer LiDAR data sets that will have those types of features in account. If it's full waveform LiDAR data that you're working with, you'll be able to see the tree canopy, things under the tree canopy, and generate a pretty nice model from that base data. Any other questions? Sir?
I know an issue that I've seen is, you know, is with regards to access is, you know, the grading and the slope of access roads, saying, well, you know, a truck's not gonna be able to get up here in the winter.
Right.
Do you have any, do you take that, are you looking to implement that kind of a solution as well?
I hadn't
Saying,
heard
here's
about-
the well pad,
Yeah.
what's the best route to get here?
I imagine it would probably be a segmented approach where you would probably do a similar procedure to at least, you know, grade a roadbed up, and that would be, you know, the decision of the project if, you know, you wanted to go ahead and do that. But not specifically. I mean, it really hinges, again, similar to this lady's question, on the accuracy of your base data that you're using. That's gonna answer a lot of questions for you before you proceed in the project, I would assume.
It just seems like this solution would be easily tailored to the.
Yeah,
the
go well
context.
together. Seth?
Isn't there some similar function that revolves around like linear features rather than pad sites, where you can draw a line for a proposed pad road and determine how much cut and fill you might need to level it out to do just that?
I think Seth just said what I was trying to say, probably a little better. There are different types of features that you can, or functions that you can do in the software that will allow you to do, say, a free-form vector that would simulate a roadbed. You could buffer it and then sync that in up to an elevation. It would calculate, you know, the break-even height of that. So,
Time for one more question?
who's got it? Last one. Thank you very much. I appreciate your time.